Good afternoon, everybody. Welcome to the Lunchtime Discovery series. Thanks for being here on this Wednesday, just a couple of minutes after 12 o'clock. Of course, we're here every Wednesday at noon, bringing you interesting people with interesting stories in science, nature, education, across all kinds of fields. We have a great program set up for you today. Of course, the Lunchtime Discovery series is brought to you by the North Carolina Office of Environmental Education within the Department of Environmental Quality and broadcasted to you by us here at the North Carolina Museum of Natural Sciences. I am your host. My name is Chris, and I'm an educator at the Museum of Natural Sciences. I'm your host every Wednesday. If you're tuning in for the first time to this series, or if you're tuning in for you can't remember how many times you've watched to this series, drop a note in the YouTube chat or in the Facebook comments. Just wave emojis or say hi. Let us know that you're here taking in today's program. As we go throughout this afternoon's presentation, remember that you can leave your questions and your comments there in the chat box and in the comments thread, so that after the presentation from today's guest, we'll actually go back and I'll moderate your questions over to today's guest speaker, and we will create dialogue and conversation around our topic for today. For the month of March, since March is Women's History Month, the Office of Environmental Education did just an amazing job of finding incredible women in science, technology, engineering, mathematics, and education from all over North Carolina to bring them here into this program to celebrate Women's History Month. Let me introduce today's guest. Candice Jordan is the Planetarium Administrator and Meteorologist for the Schiele Museum. Candice, welcome.
Hi, how's everybody doing today?
Well, I'm doing pretty good.
Yeah, hopefully you're doing well. Put in the comments below how you're doing today. You know, today is St. Patrick's Day, so hopefully you've got your green on. So also post in the comments what you are having just luck happening today. Like today I hit a lot of green lights. That is lucky.
I will nice. Yeah, take those anytime. Unfortunately, museum polos in Raleigh are all blue. So I had to turn on the green studio lights in order to celebrate St. Patrick's Day. I hope that counts.
It does.
At least a little bit.
It counts, okay. For sure.
Candace said it counts, everybody, so we're A-okay. Well, Candace, I'm looking out the window of the studio here, and at least in my part of North Carolina, we're having sort of a gray, misty afternoon. Mm-hmm. And I see in the presentation that we're going to talk a little bit about weather, but maybe not the weather that I'm looking at outside my window.
Yeah, we may touch a little bit on the weather that's outside your window, but we're going to go way outside your window. So let's get started. So what I'm going to do is share my screen here. Let's get this started. All right, so here we go. This is Head in the Clouds, Eyes on Space, and specifically for the Women's History Month. So we are going to be talking a little bit about that as well. So a little bit about me. Hi guys, my name is Candice Jordan. Yes, I am as funky and quirky as you see in that picture right there. I like to have a lot of fun. I'm the Planetarium Administrator here at the Schiele Museum. The Schiele Museum is located in Gastonia. If you have no idea where Gastonia is, it's like a hop, skip, and jump outside of Charlotte. So we're right down 85. So I basically control everything that's weather and space here at the museum. So I'm very fortunate to be working as the Planetarium Administrator. We are the second largest planetarium in the state, which is exciting. And that's been really beneficial here during COVID times, because it means even with reduced capacities, we are still able to serve about 47 people each show, which is really exciting. So things have been going well here. I am also a meteorologist, so my degree is in meteorology. I actually got my degree back at UNC Asheville in 2014, so go Bulldogs. And I used to be a TV meteorologist. So for all of you living out in Eastern North Carolina, if you go back in your memories to about 2014 to 2016, I was a meteorologist at WNCT. So you may have heard of me. My honor name was Candice Then I used my maiden name. Now I'm using my married name, Candice Jordan. So either one of those is me. But yeah, I had a really good time working as a TV meteorologist. I just really enjoy the museum life a little bit better. So we'll talk a little bit more about museum life. I am a wife, a mom, and nerd alert, I'm a huge nerd. Just know that. So there's my two kids there. I have a raging three-nager. His name is Thomas, and I have a terrible twos coming up with my littlest one, Caden. So they keep me very, very busy. I'm also a women in STEM. I'm a huge factor in promoting the whole women in STEM, which is why I was so glad to be a part of this. There's a picture of me holding a meteorite, and I love getting to talk about science with people, which is so exciting. I actually started that back when I was on TV. I started this thing called a Sunday Science Tidbit. And it was literally like, let me tell you something really cool and that's really scientific, but break it down in terms that like everybody can understand. And I'm going to do it over your TV. So you're going to be educated in this newscast, which I did every Sunday. And then I'm also a lover of puns and memes, and I love Disney World. So there's my husband and I at Disney, and you will probably see several memes in this program, so just go with it. Once again, I love memes. Actually, I have a sign outside of the planetarium that says, I need my space, and it says, please social distance. So yes, I'm very passionate about that. So here at this show museum, who runs the Schiele? Women! So almost all of our educators here are women, which are amazing. So you'll see some of their pictures coming up here soon. We're all degreed, and some of us even have master's degrees. We have degrees in biology, meteorology, science education, wildlife conservation, anthropology, museum studies, field studies, archaeology, history, animal sciences, and biological sciences. So we really cover a lot of different fields, and a lot of us are NCEE members, which is exciting. But shout out to all the women who run the Schiele Museum, because we're the ones putting on programs for you guys. And even our director is a woman. So it's really awesome. This is actually my first job that I've had that I've actually been in a female dominated presence. When I was working on TV at WNCT, I was the only female meteorologist. And there for a little while, I was the only female in my market. That meant the 29 counties we covered, basically from I-95, Wilson, Edgecombe counties eastward, and then from the Virginia border all the way down to the Onslow County. All those counties, I was the only female meteorologist there for a little while. So I've always worked in a male-dominated field, so it's very nice to kind of have that female-dominated presence coming through at the Schiele Museum. So now let's talk about North Carolina's weather. I'm sure you all have your favorite things you'd like to talk about North Carolina. You'll see some of those memes there. That's actually some video of me doing the weather forecast in Eastern North Carolina. One thing here at North Carolina, we have mountains and we have beaches, and that really plays a role in our entire weather patterns. It means we can get tropical stuff. It means we get this thing called the Bermuda High. A high pressure system rotates clockwise. So if you stick it just off the coast of North Carolina, it means we're going to catch that southerly flow. And boy, does that mean heat and humidity during the summer. You can all nod your heads at that. Raise your hand if you actually like heat and humidity. There should be no hands in that comment chat, by the way. All right, now we do get tropical weather around here. So we have to deal with tropical storms, with hurricanes, especially along those eastern counties. You know, we do have to worry about potential landfalls. I mean, if you're over in the Charlotte area, give me one famous hurricane. Go ahead and put it in the comment below. And I bet a lot of you just said Hurricane Hugo, 1989. That one was one that was really prevalent in people's minds over here in the Piedmont. Now, if you go over to the coastal regions, you may hear things like Florence, Fran, Floyd, lots of F's. Unfortunately, even Matthew, several ones that come through that can really cause some devastating things. I actually got to work a few hurricanes, and as cool as it is as a meteorologist to look at the science, it's really hard to sit there and have to report that, the Neuse River is overflowing its banks for the umpteenth time this week, and we're hitting record high flooding. So it is something that we have to look at. Now, not only with tropical weather, here in North Carolina, we deal with cold air damming. And if you have no idea what that is, where have you been all winter? So cold air damming is when we have cold air. If you think about cold air, it sinks, hot air rises, cold air sinks. And when it sinks, it gets banked up against the mountains. And so what happens is that it doesn't go anywhere. So that means down near like Rock Hill, upstate South Carolina, they may be in the 70s and we're stuck in the 40s with this awful rain here in the Charlotte area. So cold air damming is something that we have to deal with. And that's why I put the eye roll there, because it's not good. It's never a good situation with cold air damming. And then lastly, here in North Carolina, we have 4 seasons. And sometimes we get those in 1 week. That's okay. We totally do it. The hottest temperature ever recorded here in North Carolina was actually 110 degrees. That was over near Fayetteville. And then no surprise, Mount Mitchell takes the cake for the coldest temperatures at around negative 34 degrees. But our average temperature here in North Carolina is about 53 degrees, roughly speaking. Now, here's kind of a cool note I want to let you know about. So Brevard, North Carolina, Hickory, and Lincolnton actually had the highest, wettest anomalies for 2020. So not necessarily like the most rain, but the anomaly from average. So it was a really wet year. And then last year, if we talk about heat, Cape Hatteras and Elizabeth City had the worst heat anomalies. So the most departure from average last year. So we can see some very extreme types of weather come through North Carolina. Now, let's expand that out a little bit. So what we're going to do now is we're going to talk about the United States as a whole. So not only is North Carolina weather crazy, the United States can be crazy. You can see that image right there. It always seems like, you know, the middle portion of the country is nice and cold, and then there's always, it's going to be Florida. And then sometimes the Carolinas can get into that little warm sector. But what we deal with is the extreme temperatures. Death Valley, 134 degrees. Up in Alaska, negative 80 degrees. So we can have those wild swinging temperatures. If you want to go just the lower 48 states, that low would be around negative 70. So overall, we're in a very geographical place. We've got the Rockies, the Appalachian Mountains, and we have those 2 oceans, the Atlantic, the Gulf of Mexico as well, and then you have the Pacific. And so what that really does for us is it pumps in the warm, moist air. We can get cooler, drier air coming off the Rockies. When you collide those 2 things, we can get those really severe weather type outbreaks, those tornadoes. So we actually are the tornado capital of the world. So we can average about 1,000 tornadoes annually here in the United States. The next, the second place person is Canada with 100 on average. So the United States really takes the cake, and it's because of our topography. It's because of the Rockies, that cold, dry, or that dry air that comes down, the warm, moist air, they interact, and well, when they spin, we get tornadoes. We are in what we call the mid-latitudes. So we're not in the poles, we're not in the tropics. And so what happens, you can see that image right there, we get these 2 different jet streams that influence our weather patterns. So during the winter time, that polar jet stream can come down a little more. We get those cold snaps and it warms up, cold, warms up. And during the summer, our the subtropical jet stream can actually help to influence and steer things like our tropical weather, like hurricanes and also thunderstorms. What I mean by mid-latitude weather is we can get a wild variation in weather because we're always fighting that cold north of us and the warmer air south of us. So all weather types are present here in the United States. We get ice, we get tornadoes, we get hurricanes. Like I said, you live in North Carolina, you've been through this before. So now let's go even further out. Let's talk about Earth as a whole. So it's a dynamic world, not only just in the United States, but elsewhere as well. So places like India has the monsoon seasons and much greater scale than the North American monsoon. But can play a role in how much rain, how dry it is. Luckily, our Earth has the habitable temperatures. So here's your extremes, the 134 all the way to negative 129. While neither one of those extremes are completely comfortable, we average at around 61 degrees around the globe. So people can live even in some of these extreme places. There are people who live in Death Valley. There's people who live on Antarctica. Yeah, they're doing research, but they technically live there. So we can live in the extremes. We have water, we have air. We've got a supportive atmosphere. Now, I say supportive atmosphere, but it's only the troposphere that's really supportive. You know, if you start going up into the stratosphere, you're not going to be able to live very well. So all with a grain of salt there. The three things I tell my second graders when they come in here and do weather programs, the three things you need is air, water, sun. All right, so we've got those things. We've got the heat from the sun, you got water here on Earth, and you've got the air from the atmosphere. You need those things to make weather. So keep that in mind as we kind of broaden our horizons around the solar system. You'll see the places that don't have those three ingredients don't necessarily have weather. And then lastly, we have this nice 23.5-degree tilt, and that creates our seasons. So every 3 months or so, we're getting a new season, and it's actually just the tilting of the Earth that allows us to have those different seasons. So pop quiz time. All right, winter time. Are we closer to the sun or further away from the sun? Go ahead and put your answer in the chat below. I'll give you a second. In the wintertime, we are actually closer to the sun, but the northern hemisphere is tilted away from the sun. So we get less direct sunlight, and so therefore we don't get as extreme temperatures. We don't heat up as well. But in the summer, yes, we're further away from the sun, but we're tilted towards the sun, so we get more direct sunlight, and that means we can heat ourselves up really well. So hopefully you got that right. If not, hopefully you learned something. So guys, I'm going to need you to go ahead and strap on in. We're going into a tour of the solar system, and we're going to start with the first planet from the sun. Which one's that one? Mercury! Yes, you're correct. Mercury is known for its extreme temperatures. You can take your vacation to the extreme. So here we go. Let's talk about the temperature roller coaster that's coming through right now. Nice, bright, sunny skies. Temperatures in the daytime can be right around 800 degrees. Your lows on Mercury at night, negative 300 degrees. Now, if you want to do some rough math there, that's about an 1100 degree difference between night and day. So there you go. The biggest diurnal change of any planet in the solar system, goes to Mercury. So your average temperature technically is about 50 degrees, but really you're going to be dealing with either the really hot or the really cold temperatures. Now there is no atmosphere on Mercury, so therefore the sky is going to look black as night even during the daytime. So you're not going to have that pretty blue sky everybody is used to, just because there's no way to scatter the light. And so that's how we get light here on Earth. It scatters the light, creates a blue color. There's no color on Mercury, so it's black as night even during the daytime. And you'll definitely want to pack the sunglasses. You see, the sun will look 3 times bigger in the sky and 7 times brighter. So definitely going to be a UV alert today. So you might as well go ahead and lather on an entire bottle onto one region of your arm, because that UV radiation is definitely going to be very intense with you being so close to the sun. The atmosphere, I say that there's no atmosphere, but there's technically a very thin atmosphere, but it's close enough to be considered a vacuum. So it's a quiet weather day every day here on Mercury. Overall, not much to talk about. So let's go on to the second planet from the sun. It's the heat that can't be beat. And you would think that the closest planet to the sun would be the hottest, but it's not. So we got a weather alert day today if you're heading out into Venus, going out for a vacation. That's because it's another hot one coming through. Temperatures are going to be near 900 degrees today. That is hot enough to melt lead, so just make sure you take all that metal jewelry off as you're heading to the Venusian surface. Your low temperatures will be right around 820 degrees, giving you about an average of 847. So overall, another hot day, a hot streak continuing. Doesn't look like any cool downs in sight. Now, we do have a chance of storms here on Venus, and it can produce some gusty winds for us. Those winds could be upwards of 200 miles an hour in those upper portions of the atmosphere. Surface winds are light and variable, though. Now, if you're heading down to the surface of Venus, just know that the pressure is 94 times greater than here on Earth. So you're going to want to wear some kind of special spacesuit. That is the equivalent pressure of a grizzly bear bite. So Just remember that as you head down to the surface. Now, if you're going to be heading up into the atmosphere, know that it is going to have a chance of rain. It might rain some sulfuric acid. We also may have a chance of snow, some metallic flakes of galena and bismuthinite can happen. So we can see those metallic snowflakes happening there. And you might also see some metallic frost on some of those mountain tops. So just be mindful, rain and snow may be in the forecast as well. Those clouds are made of that sulfuric acid, so not necessarily something you want to be spending a whole lot of time in. And really, those clouds are the reason that we're going to keep temperatures so high. We're going to keep them over through the weekend and for the foreseeable future. Those clouds are made of carbon dioxide, so not something you want to be breathing in. And it also acts as a giant blanket, helping to keep those temperatures nice and uniform across the entire planet. All right, well, if Venus is not doing it for you, why don't we go to the moon? It's our next door neighbor, right? You can practically catch a ride up to a hotel and then maybe just, go right ahead and go on to the moon. Well, it's going to be wall-to-wall clear skies on the moon today. You see that we don't have that atmosphere on the moon, so therefore we will see nice clear skies, not a cloud in sight. Now that stagnant Arctic air near some of those craters at the poles is really setting in. That's going to drop those temperatures down to negative 387 degrees. But don't worry, on the daytime side of things, it can get up to 253 degrees. You see, we get about 13 days of daytime and about 13 days of nighttime. That gives us about a month worth of day to night cycle. Now, your average temperature on the moon is about negative 67, so definitely want to pack an extra jacket if you're planning on going to the moon. Now, like I said, no atmosphere, so once again, the sky will look black as night, even in the daytime, so don't worry, you're not going to see any colors in the sky. You'll see the nice bright sunshine, but make sure to pack that spacesuit. Once again, we will be dealing with the cooler temperatures and the lack of air. That's not fun. Also, fun to know, if you were able to take your space helmet off and stand right next to your friend, that lack of air means that it's a quiet world. You could scream as loud as you want in your friend's face and they would never hear you because there's no air to carry those sound waves. Now, overall, because there's no atmosphere, there's not really any weather, it's a rinse and repeat forecast each and every day. So let's go to Mars. Mars is all the rage right now. You've got Perseverance hanging out on Mars. You'll see some images from Perseverance coming back from our live reporting there. And it looks like a sunny start to our days. Really, sunshine is going to take the cake for Mars. Overall, it's a very desert-like world. Temperatures can top out near 70 degrees, which is really exciting. How many of you like sunny and 70 degrees? Put it in the comments below what your favorite kind of weather day is. Oh, sunny and 70 degrees, that's totally me. But you're going to have to go to the right regions of Mars in order to see that. You see up near the poles, it's going to be around negative 220. So really plan your location. Remember, when you're going on vacation, location, location, location. There you go. Your average temperature here on Mars is about negative 81 degrees. Now, our frost is going to be returning. You can see sometimes we get that frost right there in the wintertime that will settle down on the ground. Overall, though, no rain in sight. In fact, we don't even really have any clouds here on Mars. You may have a few wispy clouds at the peaks of the mountaintops, but really that's going to be it. The atmosphere is about 1,000th of Earth's, so therefore it's really, really thin. Can't support the weather that we would normally see. So be mindful though, dust storms are all the rage on Mars, and sometimes they can envelop the entire planet. So just make sure you have that in mind as you're heading out. Make sure you have your goggles and your space helmets ready. That dust storm can be pretty intense. And with those dust storms comes the risk of dust devils over the next couple of days. So make sure you're planning ahead for those and have your emergency plans in place. Let's head on over to Jupiter. Jupiter's the biggest planet in our solar system. And now we're going to start switching up from those rocky planets to our gas giants. And what does that mean for weather? Well, it means there's a Category 6 hurricane that's been lingering on the surface. You can see it right there, that great red spot. That is a hurricane on Jupiter that is twice the size of Earth. There you go. It has winds well over 200 miles an hour. And it's been going on ever since the 1850 when we really started to look at this. Now we have noticed it's been shrinking. It used to be about 3 times the size of Earth. Now it's only 2 times the size of Earth, but overall still continuing to rage on. Now that's not the only storm in our forecast for Jupiter. There are other swirls and whirls in the atmosphere that can create the very stormy pattern. So overall, if you're looking for a good thunderstorm, Jupiter is where you would like to vacation to. You see, Jupiter, Venus, and Saturn are the elite group, along with Earth, to actually have lightning on it. So we've actually detected lightning on Jupiter in some of those storms. Now, because the gravity and the density and everything is so different, that thunder would sound like a really low rumble. Now there is rain and ice expected. You can see those ammonia rains coming through. Overall, not a pleasant rain to be out in. And sometimes if it is cold enough, we can get those ammonia crystals to crystallize right there in the atmosphere. It's seasonal year round. It's not very tilted like the Earth is. So overall, it's a very uniform kind of weather pattern. You can see those storms there. That right there is a really cool phenomenon here on Earth called sprites. It's a type of electrical discharge, and we can actually see sprites on Jupiter as well. Temperature is definitely going to be near the negative 238 degree mark, winds peaking at 400 miles an hour. So go ahead and put the extra spritz of hairspray in there if you're going to be heading out, and make sure to grab the big jackets for those negative 200 degree temperatures. Now let's head on over to Saturn. So Saturn, the polar vortex is back. Ooh, it's not a new concept. But the polar vortex on Saturn is hexagonal. So it looks like a hexagon. Here on Earth, our polar jet streams actually kind of make these wave patterns. So you'll see kind of this wave coming through, and that's why our weather patterns come every few days. Well, on Saturn, you can see here it's a nice hexagonal shape, which is a very odd shape to have. So very cool, something scientists are really wanting to study there. Now, if you're heading out to Saturn, not only do you have to deal with the polar vortex, we've got the bigger dip in temperatures. So now temperatures are going to be ranging around negative 285 degrees, but those winds are starting to pick up. So expect gusts up to 1,000 miles per hour. Yes, that is greater than the speed of sound. So just know that anything that you yell, the wind will go faster. You can see right there that has been spotted some lightning also on Saturn in some of those storms. So storms are back in the forecast. You can see right there, that one's called the Rose storm. It kind of looks like a rose. But all these swirls and whirls are causing that. Now, there are clouds on Saturn, kind of deeper down in the atmosphere. They're a nice deep red color thanks to the hydrogen. And then above, you've got the ammonia that's a more of a white color. So when you kind of combine those two colors together, we get that pale gold. And so that's the reason that Saturn has that nice pale gold color. Now, it's not like you can land on Jupiter and Saturn. They're really just gassy planets. In fact, you get this weird substance on Jupiter that's called metallic hydrogen. Very weird concept to think about. Now, what we did notice with one of our spacecraft flybys is that Saturn actually has a hurricane on it that actually had an eye, just like here on Earth. And it's the only other planet that we've seen kind of an eye in a hurricane, which is really cool. So like I said, extra spritz of hairspray today as that 1,000-mile-an-hour winds are going to be occurring. And you might even be able to see the aurora in some of the extremities at the poles of Jupiter and Saturn. So let's go to Uranus. You may also hear it called Uranus. Either one is correct to say. It just depends on who's telling the butt of the joke. So here we've got the extreme cold temperatures. We are much further away from the sun than even Saturn is. And so those temperatures dip down to negative 353 degrees. That's a chilly one. That's a chilly start. You might want to have an extra cup of coffee with that. The winds will be up near 360 miles an hour. Now, 98 degrees. We're not talking about the fan, guys, and we're not talking about the heat. That is the tilt of Uranus. And so what that means is that those seasons are like 21 years long. So if you don't like winter, guys, it drags on for 21 years. Now, wind chills will be a factor today with that 360-mile-an-hour winds. So just know that that's not going to be good for any kind of skin exposure. You might want to have an extra suit on. And violent storms are expected, especially when we transition from the winter to springtime on Uranus. You'll see that frosty conditions where it's been stuck in the cold for 21 years starts to rapidly heat up. And so it can create those violent storms. So storm seasons, just like here on Earth, springtime is our thunderstorm season, same thing on Uranus. Now, here we are on Neptune, windy, once again, trash can alert. You'll need to put your trash cans up if you're on Neptune. Those winds are going to be right there near 1,200 miles an hour, giving it the designation of the windiest place in the solar system. You'll have to watch for scooters. Scooters are clouds that go around Neptune once every 16 hours. So that's a really, really fast. There was this place called the Great Dark Spot. It's like a hurricane, kind of like the Great Red Spot on Jupiter. You can see a picture of it there, but it has now dissipated. So luckily we're not seeing any action from that anymore. Those ammonia ice crystals and methane crystals will be continuing to be expected on Neptune. In fact, all of our gas giant planets, Jupiter, Saturn, Uranus, and Neptune, it can rain diamonds. I know, let that just sink in for a second. It can rain diamonds. But unfortunately, due to the pressures, once you start getting deeper and deeper in the atmosphere, it actually just kind of melts and like gets rid of those diamonds pretty quickly. But really kind of neat to think about. Now, Neptune here is about 2.8 billion miles from the sun, so really, really far away. And it's so cold on Neptune. It's only about, actually on Triton, so one of the moons of Neptune is about negative 391 degrees. That's so cold that it's about 68 degrees or so above absolute zero. That's the point where molecules stop moving. Like, so this is like the frigid Arctic air doesn't even describe what's happening on Triton and Neptune. Now, we're done with the planets, but you know, there's one little guy that we always got to talk about. Let's go out to Pluto. You know, it's our favorite correspondent to go to. It's now a dwarf planet. And let me make a little caveat here with Pluto. Everybody says Pluto got demoted. Pluto did not get demoted, guys. All right, Pluto got promoted. All right, and I'm going to tell you why. Because Pluto made us totally rethink astronomy. It made us totally rethink how we classify planets in our solar system. So I don't want anybody hating on Pluto, okay? Remember, Pluto got a promotion. It made us scientists really rethink how we think about astronomy. So remember that. All right, now let's talk about Pluto's size. So here, I've got a little trivia question. You can go in the chat below. All right, so do you think Pluto is bigger than the United States? Is it smaller than the United States? All right, put your answers below. Bigger than the United States or smaller than the United States? I'm gonna give you time to answer. All right, well, we're gonna do some math today. Math, you're like, no, I didn't sign up for this. I promise it's easy. We're gonna round some numbers here. So the United States is about 3,000 miles across. We're rounding. All right, so we're 3,000 miles across. Now, Pluto is about 1,500 miles across. So if you do some simple math, Pluto is about half the size of the United States. So if you said smaller, congratulations, you were right. All right, so you may have heard of the heart of Pluto. You can see it right there in some of those pictures. It's actually a place where you have nitrogen ice, which is kind of cool. So there is a thin atmosphere on Pluto, and it's so thin it extends about 100 kilometers off the surface. But whenever it gets into like its wintertime, its cooler phase, the sky falls. I like to say the sky is falling. It actually freezes onto the surface of Mars, and on Pluto. And when it warms up, it goes back into the atmosphere as a gas, and then it'll freeze back onto its surface. So it's kind of a fluctuating atmosphere that's occurring. So that is a heart of nitrogen ice. And that heart kind of doing its melting and refreezing actually helps to make the wind blow on Pluto, which is really exciting. So overall, there's uniform temperatures. They range from about negative 370 to negative 390. So your average is about negative 388 degrees. Either way, definitely going to need the heated suits when you go out and about on Pluto. Overall, it's going to feel like twilight, not the series. All right, twilight, because you are so far away from the sun that you know that awkward in between. I know when you're driving, think about that awkward time where it's kind of like it's still bright enough outside you can see, but it's like dark enough you feel like you can't see, that like awkward in between time. That's what it's like there on Pluto, but basically like all the time because it's so far away from the sun. All right, guys, are you ready to see another planet? Now, this one's not in our solar system. All right, tell me how excited you are to see another planet that is crazy extreme. All right, you guys ready? And it has a really catchy name. All right, you guys ready? It's called HD 18973b. Remember that one. All right, but this is an exoplanet, so a planet that's not around our sun. And let me tell you all about it. Now, first off, it is a blue planet. We're like, woohoo, blue. Blue means life, right? I mean, like blue oceans, yeah, awesome. No. You see, Neptune is blue, but that's methane. All right, this guy here is blue, but for a whole nother reason. So I'm giving this one the distinction of an extreme weather alert day. Yeah, this one calls for all the bells and whistles to go off. Breaking news, extreme weather alert day. Woo! That's one of those days because it has those misleading blue skies. Those blue skies are actually a blowtorched atmosphere full of silicate particles. Ugh, sounds awful, right? An umbrella's not even going to help that. It's a super skirt alert day, guys, because temperatures are going to be near 2,000 degrees. Your wind speeds are near 5,400 miles per hour. Yeah, that's bad. That's 7 times the speed of sound. So it whips on this world. Now, if that's not bad enough for you, I like to put the boating forecast. I used to work in Eastern North Carolina, had to do those boating forecasts, and we're calling for glassy waves. But what I mean is that it actually rains like molten glass. So when it falls and the wind catches it, it rains shards of glass on this planet. Ugh, that's not a good thing. And then, like I said, your AC will be working on overload as temperatures are near 2,000 degrees. Even on the nighttime side, you'll see it at around 1,200 degrees. So overall, guys, not a good place to live, but a fun one to sit there and study as a scientist. So raining molten glass on a superheated, really windy world. There you go. All right, so here at the Schiele Museum, we nerd out about stuff like this all the time. We do a program called The Sky Tonight, where we literally just talk about random stuff like this. We do things called Weatherproof. That's where I just geek out about weather things, and it's a ton of fun. And we also have this little series going on. It was called Weather Wednesday. Now it's called What's Up Wednesday, where we just basically tell a random weather or space fact every Wednesday on social media. So that is kind of our little piece of weather and space here at the museum, and you get to get all this nerdiness all the time, which is a ton of fun. So now I'm going to turn it over and we're going to do some Q&A. So I'm going to stop sharing my screen and you should see us now, and let's do some Q&A.
All right. Candace, excellent presentation.
Thank you.
Absolutely brilliant. I think I've seen some of those graphics on the TV before.
You may have.
I think I recognize a little bit of that. But excellent job. That was fun. That was so much fun. We did a whole tour of the solar system.
Woo. On a lunchtime
All we need now
break.
is the rocket to get us there for these vacations.
Exactly.
So I'll remind everybody, drop your thoughts, questions, comments into the chat box, into the comment box, and I'm going to grab those and we'll pose those to Candace. Now, the first one is actually one that I was thinking about earlier in the presentation, and that is, I've been fortunate to be outside during a solar eclipse when we had,
2017.
Yeah, 2017. And I'm curious if there are similar weather changes on places like the moon that experience eclipses or other planets?
Yeah, so not necessarily on the moon will it experience different like weather changes, but actually here on Earth, if you're actually in like the heart of the eclipse, like the places that see total like totality, there are actually noticeable changes because you do lose the sun's heat for just a few moments. It gets cooler. And that actually signals like birds and different animals, they realize that it's darker, it's getting cooler, and so they will actually start their like nighttime routines. So whatever, you know, a specific animal does. But yeah, scientists actually were setting up like weather stations along the path of totality, because you can notice like the wind changes a bit, the temperatures change a bit. So it really does have implications for us. A lot of people don't realize just how much the sun does for us each moment until something like that happens and you realize we really do cool down. And imagine if the sun was gone. It cools down like that in a few minutes. Imagine if it was gone. Whoa, totally different story. Good question.
Excellent stuff. All right. First question in the chat box that I see. We know Earth has seasons due to the tilt, but do any other solar system planets have anything similar to seasons?
Yes. So there are several planets that have kind of really set seasons. Now, it does take an atmosphere to see the bigger changes in seasons. So like Mercury, it's just hot side, cold side. And it doesn't matter how it's tilted, it's hot side and cold side because there's no atmosphere to kind of help circulate that temperature difference and such. But places like Uranus, because it's tilted pretty much on its side, it has seasons that are 21 years long. They're so long because it's extremely tilted. Jupiter isn't tilted very much, so there's not really a seasonal change. I'm trying to think. I know Mars has different seasons, and it's tilted similarly to Earth, so it's similar-esque seasons. Really, it's just the presence of our atmosphere, our vibrant atmosphere that allows us to have those dynamic seasons. You don't really see super huge dynamic seasons kind of like we do here, but like they can be much longer. Just like with Uranus, you have the really cold temperatures and then you get those violent storms when springtime rolls around because everything starts to heat up a little more and you have 21 years of heating up. So you can get those really violent changes in atmosphere.
All right, excellent. Great question there. All right, let's see. User NC Hurricane is curious about. do we know NC Hurricane?
I do.
Oh, perfect. Well, you're gonna love this question then.
All right.
Well, first they said this is awesome, thumbs up.
Yay!
But I think in relation to that planet HD 3.141592 or whatever, whichever.
Yeah. They really catch it.
They wrote 2,000 degrees, but is it a dry heat?
Oh, well, I mean, there is like the molten glass in the air, so you're probably getting a little bit of humidity, but by the time that it starts to cool and come down to shards, are we really worried about the humidity? But yeah, it's probably a dry heat. Sure.
Very good perspective. All right, JC wants to know, what is the most habitable planet you listed today? And I'm going to put the caveat besides Earth.
Mars for sure. Mars is definitely our next habitable place. Venus would kind of be there if it didn't have those thick clouds that have such carbon dioxide and that greenhouse effect going wild. Otherwise, it would have like liquid oceans on it, but those oceans are just totally gone now. So definitely Mars, and I think that's one reason why scientists are really interested in studying Mars, because if we can overcome these little hurdles that Mars throws at us, we can potentially live there. I mean, like I said, temperatures can reach a maximum of 70 degrees. People live in, 10-degree weather all the time. So, I think Mars is definitely our next stop as far as humans go.
So I'm curious, you're a trained meteorologist. How do the tools compare for doing meteorology on Earth compared to what you know about tracking weather on other planets?
Yeah, so we actually use a lot of similar things. Now, here on Earth, we're lucky because there's actually humans here. We put lots of weather stations down, which, hint, hint, if you're not a CocoRoz observer, this will be a great time to be one. Just saying, you can do weather in your own backyard. So it's a citizen scientist project. But we have weather stations that directly measure the weather. Now, on other planets, we're not directly measuring it. We're using indirect methods. But things kind of like satellites, we use weather satellites here all the time to measure clouds, hurricanes, different things like that. So we're using satellites and other imagery to measure things on other planets. Think about like the Juno spacecraft as it goes by Jupiter, Cassini when it was going by Saturn, the New Horizons with Pluto. And then we've actually had rovers on Venus before. It was the Soviets. This was kind of way back in the 1970s. They only lasted like 30 to 50 minutes because of the intense heat and pressure, but it did capture some real-time data of the surface. But yeah, overall, lots of indirect meteorology happening with satellites and just looking at colors, spectrographs, different things like that to kind of infer what's happening.
All right, excuse me. Okay, let's see here. Brian has a great question. For giants that have an atmosphere, let me catch my breath. It's such a good question. For giants that have an atmosphere, where does atmosphere end and planet start?
All right, so places like Jupiter and Saturn, it's a gas giant. Even Neptune and Uranus, they, especially like Jupiter and Saturn, there's a core. It's still debatable with some scientists on what it's like because we can't directly measure it, and it's really hard to kind of penetrate through those really thick clouds. So there's not a real definition of where atmosphere in core begins because you're getting these like weird substances like plasma and like metallic hydrogen and really things that we don't experience here on Earth. So it's a very abstract thought to begin with, and then you're trying, to put those limits on there. Even here on Earth, our layers of the atmosphere are very fluid. So, the stratosphere starts at 5 to 10 miles above our heads. And it's for that reason because it's much shallow in the poles, but in the tropics, you can have the troposphere be about 10 miles high. And our exosphere, and depending on what you want to call it, some say the exosphere, ends when there's no more air molecules. Some say that our moon is in our exosphere. So there's a lot of fluidity there with those hard limits. But just know those big gas giants, they are pretty much all atmosphere. Then there's some kind of something in the middle. Good question.
Right. Very good questions. And let's see. It looks like we exhausted. You were comprehensive and thorough.
Yay!
and the chat has fallen
all right,
quiet with
then
questions.
Let me do this. Shout out, guys. Which one was your favorite planet to learn about?
Let us know.
Comments in the below. Know.
I'll say my favorite one to learn about is probably going to be Venus. Mm-hmm. I'm always fascinated by Venus, mostly because of the extreme heat.
Yeah.
And because of the analog that it provides for human-caused climate change here on Earth. Yep. Right? It's a really easy point to. It's 900 degrees on the surface of Venus, and that's because it has a thick blanket of carbon dioxide in the atmosphere, that traps heat and scorches everything.
Yeah.
Now, on Earth, guess what? We also have a growing atmosphere of carbon dioxide. More carbon dioxide is entering the atmosphere. So if this is what happens to Venus, I don't think we're going to scorch the surface of Earth anytime soon.
Yeah.
We are going to warm things up just a little bit.
And I think that's an important part, for everybody who's out there listening. In social media, it is what it is. But, there's some misleading information that can be on social media. And I think one thing to know is like, just because we had, an 80-degree day in February, or because we had like temperatures below zero somewhere, that doesn't like necessarily mean climate change, but it means long-term patterns. So when we're talking about the fact that like Hickory and Lincolnton saw, the biggest wet anomalies in 2020, if these keep happening for years and years, that's a pattern that's occurring, and maybe this pattern is because of human interaction with climate change. So, I think that's a huge distinction that a lot of people are like, oh, well, it's cooler, so it's not global warming. You can't look at day-to-day things. You have to look at like month to month, year to year, averages. Our averages are going up each year. So I think that's something that people need to know is like there's a huge difference between weather and climate. They're related, but they're like related like this.
Yes, exactly. Very, very good point. Absolutely. Let's see here. Marty is we were asking people about their planets. Deb likes Uranus. Marty agrees that Venus is great, but he's also very interested in the moon Europa.
Oh, I know. Europa is so cool. So side fact, Europa has like these an icy crust, but scientists have found there is more liquid water underneath that icy crust than there is here on Earth. So, it's just a matter of like us having to actually like study this in more detail. Could there be life underneath the icy crust of Europa? Woo! There's so much cool stuff happening in space, like geek out moment.
Let's see. Carl writes their favorite is HD 189733.
Right? I mean, like, how cool? You can't. It's one of those things like I never want to visit. But I mean, how cool is it that like it rains shards of glass and it's 2,000 degrees and the wind is like 7 times the speed of sound? No big deal.
Okay. Here's another question just came in. Great. Thanks, Chris. I've heard a theory that the core of Jupiter could in part be made of diamond-like materials. Is that so?
I mean, it's definitely a possibility. The one thing is like when you start getting down into the core of Jupiter, one like the core of Jupiter is hotter than the surface of the sun. It's like 43,000 degrees or so. The surface of the sun's like 10,000 degrees. So like this is extremely hot. Like this is like as hot as a lightning bolt. And so once you got like all that intense heat, and then once you start getting down into the depths of Jupiter, I mean, you're getting some like really intense pressures. So theoretically, I mean, diamonds are super strong. You're having to like give a lot of pressure to make a diamond. So theoretically, it could happen. That's why I said it rains diamonds sometimes on Jupiter. But by the time you get down to that intense heat, those diamonds start to like melt. But yeah, it'd be really cool one day if we could actually like see or like really figure out what the cores of some of these bigger planets are. Like Jupiter, for example, it's like a hop, skip, and jump away from being its own star. It's just too cold to make it happen, but it has the same property as of a sun. It's just way too cold to make any kind of nuclear fusion and fission happen.
All right, excellent stuff. Well, Candace, thank you so much.
You're welcome.
If folks want to keep up with what's going on at the Schiele, how can they do that?
The best way is to go to schielemuseum.org. That's where everything's happening. You can also check out our Facebook page. They're really good about kind of keeping our events and everything updated on Facebook. And on our website, my email is on there. So if you ever want to chat, just feel free to shoot me an email and we'll chat. Like I said, I'm not a huge nerd or anything, I promise.
Well, in that case, okay, another question just popped up. I have to ask it because it's so great. Vivian, age 10, wants to know what would happen if a lightning bolt hit the sun.
Oh, if a lightning bolt hit the sun. I don't think anything would really happen. One, because like if you're thinking about a lightning bolt, like here on Earth, even some of our bigger lightning bolts, they're going to be like a speck of dust on the sun. And so, I mean, you would have a little bit of electrical discharge, but nothing compared to the sun. The sun is doing much more in the way of like crazy convection and all that stuff than a lightning bolt would. But yeah, if you had like a mega like Zeus lightning bolt, I guess like you could do some stuff with the sun, but nothing that I can think of. There's not enough like electrical charges to make it happen out there right now.
Vivian, go look up solar weather like flares and coronal mass ejections. They're a
Yeah,
little bit more exciting than
there's actually a
lightning
whole
bolts.
branch of science called space weather, and that's where they look at solar flares, things like geomagnetic storms. So like you'll get alerts. Well, I say you. I look at different things like that. You can actually see like what class of storm we're going to be in, and sometimes that can impact things like our satellites and other things like that, different electrical components.
All right. Well, that's going to be our show for today. Candace, thank you one more time. Thanks everybody for tuning in to another great edition of the Lunchtime Discovery series. Thanks to the folks at the Office of Environmental Education and the team behind the scenes at the Museum of Natural Sciences with us who make sure that this show goes out every single week. We will be back, of course, next Wednesday at noon with another special lecture for Women's History Month. So make sure that you check out eenorthcarolina.org. That's the website for the Environmental Education Office. There you can see the schedule of events, see what programs are coming up for the rest of the month. You can also sort of do a one-stop shop. You can get the schedule for this lecture series and all of the other great virtual events we host at the museum at naturalsciences.org. And as always, you can follow the Environmental Education Office on Twitter. They're at North Carolina EE. And we, of course, are at Natural Sciences on Facebook, Twitter, and Instagram. So everybody, enjoy the rest of your Wednesday. Take care, stay safe, and keep your community safe. We'll see you again soon. Bye, everybody.